In this problem, we have a cart being pulled by a string that's attached over a pulley to a mass. The first thing I think about in these types of problems is to draw the forces acting on each object. So on the cart, we have the force of gravity, or the weight, balanced perfectly by the normal force, and a tension to the right. On the mass here, we have its weight, and the tension. So I'll write the sum of the forces for each of these guys. I'm not so concerned about the sum of the forces in the y direction for the cart because I see that they perfectly balance out, and the only thing it would tell me is that the weight is equal to the normal force. But in the x direction, we have tension pulling to the right, and that's going to equal to the mass of that cart times A. And the mass of that cart is 1 kilogram. And so we can say our tension is equal to A. Looking at the falling mass, we can say that the sum of the forces, well, first of all, since this cart is going to slide to the right and I made that positive, this is going to slide down, I have to make that positive. So I want to write Fg minus the tension equals Ma. The mass of the falling weight is 2 kilograms. So its weight is 2 kilograms times 9.8 meters per second squared, minus tension equals 2 kilograms times A. Well, I have two unknowns here. I don't know the tension and I don't know the acceleration, but here I can see that tension is equal to acceleration. So I'm going to plug that in over here. So I get 19.6 minus A equals 2A. 19.6 is equal to 3A, and A is equal to 6.5 meters per second squared. Now we've done a lot of other problems where we'd have to consider how hard it is to rotate this pulley, but because this is a lightweight frictionless pulley, we can ignore that it takes any energy at all to rotate that pulley. So now I want to experimentally determine the acceleration. I have a pair of photo gates, so I'll place one right here. Photo gate 1. And I'll place another one a known distance away. I guess a meter might be a good distance. And I'll put photo gate 2 right there. So if I release this cart from rest, if V initial is 0 meters per second, and the distance is known as 1 meter, and I time it with the photo gates, then I can use the formula D equals VIT plus 1/2 AT squared, crossing out VIT because the initial velocity is 0, and I know the acceleration will equal to 2 times the distance, which is 1 meter, over the time I get off my photo gates squared. Again, there are multiple answers for why the acceleration might be slower than you predicted in part A. One is because of the friction between the tire's axle and the car, which would have slowed it down. Maybe the table was not level. Keep in mind that you should probably say that it's higher on the right side, preventing that cart from going up with the same acceleration that you would have expected. I'm sure there's other answers you could think of, but these are two acceptable ones.